everyone, and welcome to another live stream on Canada's Technology Triangle.net user group. Tonight we have Roy Kim back to talk to us, and we'll be presenting about Kaito and operator streaming, AI, ML, inference model deployment in Kubernetes. So a little bit about Roy. Roy Kim is an Azure cloud architect and engineer. He focuses on DevOps, Terraform, and various Azure workloads for small, large enterprises. And comes to us with a lot of experience with Kubernetes. He's also Microsoft MVP in Azure since 2017. And you can reach Roy over at roykim.ca on his blog. So welcome, everyone. Hi, Roy. Thank you for joining us tonight.
All right. Awesome. Yeah, thanks for having me setting this up together. Okay, cool. So let's just get started. Let me present my screen here.
Yep, let me get out of the way myself.
Okay.
Oh wait, just a quick word to anyone out there on who's watching us live. I'll be posting some questions in the chat. If anyone has questions, comments, please ask away, and we'll save our questions for the end with Roy. But definitely looking forward to any kind of interaction that we can do. Okay.
Okay. All right. You guys can see my screen here. Okay. All right. Yeah, thanks for hopping on. If there's any questions, feel free to ask. I would love questions and discussions. That's what I'm here for. It's for you. Okay, so title is deploying Falcon and Phi-3 language models on AKS with the Kaito add-on. But I'll talk more about the Falcon large language model family. And So what is this Kaito operator, right? It stands for Kubernetes AI Toolchain Operator. Okay, so it's like a feature set that you can set up on Azure Kubernetes. Okay, so it's an operator, Kubernetes operator kind of pattern that automates the AI and ML inference model deployment in a cluster. So you can run, machine learning workloads and LLMs in a cost-effective way. Okay, so you would mostly be like maybe used to or like Azure OpenAI service, right? Or OpenAI or like third party that you just call its API. Okay, but what about if you want to deploy LLMs, within your Kubernetes cluster, kind of locally, okay? So you don't have to rely on a third party, and also data is also kept, within your network and in your Kubernetes cluster, right? So you have more control in that way. So that's what Kaito brings. Also, if you didn't have Kaito, then you would have to, write all these scripts to, spin up a node pool, try to get your GPU and deploy the LLM. Also, like tie in things like permissions between services and infrastructure components and all that stuff, right? So really, Kaito streamlines all that with you, and I find that pretty cool. So Kaito right now supports some LLMs at the moment, not all of them, because if you go to Hugging Face, there's like literally like 100,000s and of models that you can choose from. But really, there's a small family of models, but one is Falcon. It's an LLM by a technology innovation in Abu Dhabi. Okay, so they've fine-tuned it, and they've used a data set of the refined web. So, and then Llama 2 is Meta, like Facebook, and they have their own flavor and the way that they use to train it, and leveraging their data sets, right, to do that. So they're very comparable. They always say, oh, one is better than the other, but they may have one maybe better than the other in some use cases. But right now, I find it very hard to kind of choose what LLMs are right for you or for your use cases, right? But it's kind of because there's so many LLMs right there, right, that but there's tools out there and benchmarks and such that you can leverage. There's also Phi-3 from Microsoft. It's more geared to be kind of lightweight, faster, probably cheaper. But yeah, you can find more details on Hugging Face and also on Microsoft's kind of website or their Azure Foundry model catalog. But those are the three kind of main ones. And of course, these are all, as of now, these are the model families that you can find on the GitHub repo, and then you can click into them, and then there's various sizes, right? Like 7 billion or 40 billion parameters, one that is meant for for chat-based scenarios, etc., etc. So you can choose, dig deep. So you can go into here. So let me show that. Let me see here. So see here. So these are the model presets. So if you go to like Falcon, and then there's 7 billion parameter, 40 billion instruct. So instruct mean kind of they're geared for like kind of chat based, where these ones is just for like kind of chat, text completions and summarization and things like that. But they're both pretty good. And then if you want to go to the model source, it takes you to the Hugging Face, and then you can see more information on that. Even I think what's cool is probably even the data set that was used behind it, etc. So anyways, find all of that there. Okay, let me go back to, so Falcon 7B is, again, 7 billion parameters, okay? And this is a pretty good one to start off with. This is the one that I'm kind of using, the instruct or the non-instruct one. And so let me show you kind of like the YAML. Actually, no, I'll show that later. Okay. But okay, so to dig deeper about like hosting local LLMs, the advantages, okay, so well, what are they, right? So first, you have control over the data, right? So for example, there could be security concerns on the data that is being prompted with, like you're sending personal information over, customer data, etc., that you want to kind of prompt on, or like the type of data that comes out, okay, and it may be kind of filtered or inspected before it returns to an end user, right, through your service, right? So it's these type of things that you want to limit these exposures when you host them locally, okay? Another big advantage is compliance and governance, right? So there may be all these regulations, kind of regulatory audits that you need to adhere by. And so again, having that control and within the network boundary, and to be able to, get a specific LLM, right, at its current state, and analyze that and then see how that works for you. Because if you use a third-party service, the LLM may change or may get updated, and it may not be as transparent, maybe such a black box. So, and then there's cost efficiency, right? So allowing your models to scale with a certain set of GPUs, okay? It could be in a shared model as well, of course. You can scale, upscale, downscale as your demand and workloads are needed. And of course, there's fine-tuning capabilities, which is pretty cool. And fine-tuning is taking a foundational model and then basically taking a data set. And usually I've seen it as more of a question and answer kind of CSV file of your that you would see in your use cases, right? So, for example, like customer service call, right? Like, for this product, what are the recommended configuration or the recommended use, right, for this, the said product, right? And then you would have an answer associated with that, right? That you want to feed the large language model, right? That's your kind of custom data. So I'm really interested in this topic, and I will write a blog post and a video, and maybe I'll do a follow-up talk on this. But it's pretty cool, and you can use, again, local LLMs, okay, in your cluster to do the fine tuning, which takes a lot of compute power. Can take many hours to do a fine tuning, a run, right? So it's things like that you may have advantages hosting locally and have cost efficiencies. And of course, model transparency, which I touched upon, is that you can select that certain model, research upon it, and because it's open source, right? Like I showed you on the Hugging Face, you see all the Python script that comes with it, the data set, etc. Right? So you have that for audibility and explainability. So okay. What does it take to deploy Kaito, right? And it's pretty complex, but I want to kind of break it down. Actually, before I go there, let me see here. So one thing I want to point out is this. See here, this article. So my learnings is really based on this. So you can look for this AI toolchain operator. Right now it's in preview, and really I go through pretty much all these steps. I kind of add a bit more to it to my liking, and I'll go through this in a bit. Okay. Of course, there's its own dedicated GitHub repo. Right here. Okay, so obviously you got to clone this, right? And then it also gives step-by-step instructions as well, right? So, so the one thing I see here is, what's it? Examples, inference. So here's the YAML files, right? So once Kaito is set up, right, and you want to use a LLM and have it and have a node pool with a certain GPU set up, you would deploy this, right? So let's take this one for example, right? So the key thing is this is a custom resource, okay, that's installed through Kaito, and basically the scenario is this, right? So you may get a requirement that says I want a certain language model, right, which is this, and I want to deploy into this node pool with this set of GPUs, right? So this is NC, means kind of NVIDIA, like, GPUs, 12 core V3, right? So I think this is like, this may have just one GPU. So really, Kaito, the kind of like that operator, will take this and will orchestrate that, right? So that's, and then that's all you need, right, to trigger that, and then you're pretty much done. So that's the whole point of Kaito, is to take these kind of YAML files that define the LLM and the compute to support it, and it gets deployed. So so that's really the bottom line. Okay, so let's turn into like, okay, how do we set it up so that we can, start to kubectl apply these things. So let me switch over to my slides. Okay, so the first step that you need to do is you have a Kubernetes cluster. Okay, so let's assume this is very vanilla, just plain, nothing special. Like a 3-node or 1-node cluster. And that's step number one. Okay. Next is to run a Helm chart, okay, that will deploy the workspace controller, okay. So the workspace controller is kind of like orchestrates and takes in that workspace YAML file that I just showed, okay. But along with that is deploys a bunch of custom resource definitions, okay. So of course there's more than these two, but these are the main ones. So the workspace CRD will be used to create an instance of this workspace custom resource, okay. In these CRDs, they're just definitions, and they get stored in the etcd database, okay. So once that's created, we need to enable some feature flags on the Kubernetes cluster resource itself, right? So we need to enable OIDC issuer and workload identity, and there's also, managed identity, right? So the reason for this is that we want to allow the GPU node provisioning, okay, which will create a virtual machine scale set, right? So we want to have a certain Kubernetes workload or pod through a Kubernetes service account to have the permissions to create those Azure resources, such as the virtual scale set. So this is kind of laying the groundwork. And kind of OIDC issuer, OIDC is OpenID Connect, which is kind of built on top of the OAuth 2.0 protocol, right? So you can have a kind of a bit of a single sign-on experience with logging in, right? So if you didn't have this, then basically you need to store like the service principal name, like credentials like the secret and client ID within Kubernetes, right? And you got to manage that, store it. Where in this case, there's like a trust between Azure Entra ID and certain managed ID, so it's more streamlined. So just bear with me. I'll keep unpacking this concept here, but we just want to enable that. What happens is that an OIDC issuer gets created, right? So that Azure AD so this issuer URL can issue tokens when it's called upon, right? So like JSON web tokens, okay, that Azure Entra ID can leverage. So of course, we need that managed identity, okay? So we can call it Kaito Provisioner, and it will have a role assignment, and just for simplicity, just have it, complete a contributor role at the Kubernetes cluster resource level. Okay, so it can make kind of adjustments from there. So once you create that, then we can kind of go ahead and create the GPU provisioner. So this is, again, another kind of Helm chart, okay, that will provide, implement the GPU provisioner based on the machines.carpenter CRD. So this is another custom Kubernetes resource, okay, that's a controller, and that interacts with the workspace controller. So the workspace controller, I believe, will interact and kind of call upon the GPU provisioner to create that node pool with the specified VM SKU, right? So next, in order for the service account to have that, to leverage the managed identity, okay, we need to create within the managed identity a federated credential. And I'll show you shortly kind of, what that looks like in the Azure portal. But the federated credential basically will have like some fields that point to this service account. And then once that's all set up, okay, what happens in step 7 is that you can start to do kubectl apply that workspace YAML, such as the Falcon 7 YAML, and the workspace controller will take that, will kind of run with it, execute it, call upon the GPU provisioner, and then GPU provisioner will be like, okay, well, I need to create a node pool with NVIDIA GPUs, let's say, right? So then what it will do is that because now it has the permissions, okay, this GPU provisioner controller through the service account, it will have that the role, okay, to create the node pool. So then once that's created, then you have this workspace deployment as which is a pod, okay, and will also pull the LLM, which is a container, right, from either a private registry or a public registry. Okay, but in this case, the Falcon 7B is from a public container. And once that's there, is the next step is to simply test it. Okay, so what I do is I just create a curl pod that will make an HTTP call onto the LLM, basically prompting it, for example, like, what's the capital of Canada, or how do you create a virtual network in Azure, and then it'll return and provide a chat completion. So I just want to pause. I'm just looking at any kind of chat comments on the side here if anyone has questions. No, okay. So I will, continue. So that's the whole flow, okay, that happens when you install Kaito, okay, which is pretty fascinating. And it was pretty good, like a learning experience, kind of knowing all the technologies and components behind it. All right. So yeah, so these were the steps if you want to see in code. And in the Azure portal, you see the custom resource that's created. Okay. And if you go to the workloads, that's the workspace. Okay. In step number 2, step number 3, you want to do AKS update, enable OIDC issuer, enable workload identity, enable managed identity as well. And so again, one big takeaway is that the issuer URL is created. So the URL kind of will look like this. Okay, that will issue kind of tokens. Okay, that Azure Entry ID can trust on. Okay. And then step 4 is creating that identity and assign the permission. So I need my subscription, the identity name, and and then go ahead and then create the identity. Okay, whoops, and then get the identity principal, and then get the client ID. And then, of course, create your role assignment. Okay, so that's that. Okay, and then what you see here is the role assignment created. Okay, assigned to the managed identity. Okay, and with a role of contributor against the Kubernetes resource. All right, and then. Whoops. Okay, step 5 again is running that Helm chart for the GPU provisioner. Okay, and this takes quite a bit of time, as well, like maybe a minute or so. And then again, you get and then GPU provisioner right here as a workload. Next, you create the federated credential. Okay, so you need the OIDC issuer URL. And also, if you see here, you need to know the service account of the GPU provisioner, right? So you have to know ahead of time kind of the GPU provisioner kind of name, and so that's how you have that relationship or that association. Okay, and once that's executed, right, the subject is assigned right here. Okay, and when you go to the portal, you have to click on federated credential. Okay, right, and then you'll see that the federated credential is created, and the subject identifier referring to the GPU provisioner service account, right, in Kubernetes. Okay, so this is a pretty powerful concept. And again, the whole point of this is that so you don't have to store your service principal client ID and secrets kind of in your cluster, and then you have to go through rotations and all that stuff, right? So it adds for a more seamless, streamlined experience. Okay, so that's so at step number 5, everything's set up. Okay, and as I mentioned, is now you're ready to deploy a LLM. Okay, as I mentioned, you want your model name and your instance type here. So a little cost awareness here is that it's really expensive. Okay, this NC 12S for 7B. You're definitely you want to kind of shut down your Kubernetes cluster or delete this workspace when you're done with it. Like I think if you leave it on for like a full day, it's like maybe like, I don't know, like $20, $30 or something like that, right? So, you know, imagine you forget it for a week. It just adds up really quickly. So you really want to be aware of that, right? If you want to do the 40 billion, you know, it specifies using a much expensive GPU. I think there's like 4 GPUs for that, and that's like ultra expensive, right? And also, of course, to get these GPUs, you have to kind of request a quota, right, for these, which is becoming really difficult, right? You have to create a support ticket with Microsoft, and yeah, if you're on a you know, like a free trial or anything like that, you probably won't get it, right? So it's pretty picky, so watch out for that. Okay, so yeah, as I mentioned, oh yeah, so the NVIDIA GPU, this one in particular, has 4, like, you know, I guess Intel or AMDs, but really it's really one GPU. I think it should have mentioned that, didn't put that in there, right? So okay, cool. So that's deployed. And when you run it, okay, when that's deploying, this takes like 12, 15 minutes, okay? And to watch it get deployed, you have to run kubectl get workspace, okay? So because it's creating that custom resource workspace, Falcon 7B, and then you're waiting for resource ready to be true, inference ready to be true, and workspace succeeded. So that will go on for like 15 minutes, in which I just kind of spinned up right before this meetup event. Okay, and then what happens is that in the node pool, when you go to the settings, you'll see a user node pool get set up. So it's user mode. There's one virtual machine. The agent node pool is my system, right? So that's what came with it when I created the AKS cluster. So that gets created. And once that's provisioned, again, that GPU provisioner, you know, created this, okay, orchestrated the creation. And then when you kind of click into the node pool, you will see kind of more specifications. You'll see the node size as specified, okay? And also when you go to workloads, right, you can see that it created a Kubernetes deployment in the default namespace. So now, okay, how do we test this, right? So let me turn to, okay, I'll do a demo. Let me turn to my VS Code. Okay, so what I have here is, okay, I already tested it, but I'll do it again. Let me see here. Okay, so first, I prepare my AI prompt. Okay, how to create a virtual network in Azure. Okay, and I'll get the cluster IP right here. That is, to the inference kind of API to the LLM. Okay, and to test it, I will run a curl pod. Okay, it's just so that I can do an HTTP call, right? So curl x post HTTP on the cluster IP /chat. Okay, and maybe I'll make it bigger here. And make sure that give it some the appropriate headers, JSON in the body prompt, AI prompt, and you can have these parameters like max tokens, etc. So okay, I'm gonna run it. And it takes some time, but yeah, here we go. So we have this result right here, right? So how to create a virtual network. Interesting. This time around, it repeated the prompt question here. And then it says, the virtual network provides a virtual network environment on a network interface that enables virtual machines. Interesting. I had better responses here. This one was pretty repetitive. Okay, but yeah, now it kind of gives the stuff like create a virtual network, create a virtual subnet, etc., and that. So anyway, so that gives you an understanding of kind of its capabilities, right? So let's try another. Let's repeat that. Let's see what kind of response I would get. Get a better response. And as you can tell, like the speed of it, it's not like super fast. Let's see here. So here it's better. So it says log into the portal, left-hand pane, select network interfaces, choose. So this is more just range. Yeah, it gives more sensible instructions, and it didn't. Although yeah, it is repeating how to create a virtual network here, etc. So again, just want to give you an example of kind of its capabilities. So let's try another one. Describe artificial intelligence inference model and what's its use. Okay, and I will run that again. Well, this one is taking quite a while. Yeah. Artificial intelligence is a branch of computer science that focuses on building computer programs to emulate human intelligence. The ability to think and respond to environment is known as intelligence. AI is a branch. Computer science goals to create intelligent software. So this is a pretty good answer, like good response, right? It's coherent, fairly grounded. Again, it concludes in a nutshell, AI uses data to make decisions, whereas rely solely on experience. So this was a pretty good response. So as you saw, like, maybe it wasn't trained or didn't have the data when it comes to with Azure networking. It's pretty niche, but in this case, it came pretty well. This response was pretty good. So that is that demo of that, and which I think is pretty cool, right? And this only becomes better. Okay, I'm just checking on the side if there's any questions. Okay, cool. So let me give a good like a little tour through what it looks like in the Azure portal. Okay, so some key things. So right here, the main things are the node pool, as I pointed out. Okay, so this is the system node pool, user node pool. Going to the nodes, there's only one, and we would see what was it? This, where's the VM SKU for that? Right here, the node size right here. That was defined in that YAML file. Let's see, we go back. And you can always like shut that node pool off individually. What I do is I just stop the whole cluster, right? And so that saves on the compute costs. Okay. Let's tour the namespaces. So first, when you do the installation, you get the Kaito workspace. Second is the GPU provisioner. And in here is that workspace controller. Okay. This helps orchestrate that. Okay. And then you have your GPU provisioner, which creates that node pool. Okay. They're all working together. And then if you go to the default, this is where I have deployed the LLM right here, right? So that is running. If we're to look at live logs, select the pod, we can see that here, here I can run that prompt again, and then you will see kind of that prompt, the service being acted upon. Let's see here. Oh, okay, it ran. Okay, so here the post chat, and yep. So that's the one that I executed. Okay. Cool. Let's see here. What else? So again, custom resources, right? Like this is the one that was custom resources that were created, Kaito workspace, etc. Okay, and I think this one as well. So these are things you want to be aware of, kind of what was created, so that in the event of like troubleshooting and that you want to be just at the least aware of. Okay. Yeah, so that's pretty much it. The main things that have occurred in the Kubernetes cluster for that. All right. So, Callan, just want to bring it to you if there's any questions.
Hey, Roy. This is good.
Hey, yeah.
Let me check the chat for some comments. Nothing at this time. Don't be shy, people.
Yeah. So, whoops.
All right, maybe I'll ask you a question, Roy.
Sure. Yeah.
And okay, so Kubernetes, right? After deploying this into their setup, what would be your recommendation for someone who's trying this and they're looking at recommendations for what kind of scaling rules they should put for this particular pod, other than no scaling at all? Like, let's say they want to get into scaling. What kind of feedback can you give or recommendations can you give on that?
Okay, so scaling in terms of like the node pool, like
Yeah,
you're gonna have one
but
node
specifically
versus two
for this
nodes.
application or this worker.
Oh, okay. Well, it depends on the LLM, right? If it's like a 70 billion, like a 40 billion parameter, or 70 billion, or like the small Phi-3, and also it depends a lot on what like apps or are calling it, right? So if there's a lot of traffic for the inference, like basically prompting and text completions and chats, then you would want to monitor its CPU capacity, right? And then scale out. But from when I look at the CPU capacity, it's probably like a small like spike each time I do the prompts, right? But in order to for the prompt to kind of respond within like like what you saw, like 15-20 seconds, I believe it needs a GPU. If it didn't, I think it would take a really long time, right? So that's my understanding, right? Because it needs that like parallel matrix calculations and all that stuff, right? So yeah, it's just depending on the amount of workload and API calls on it. Probably when you're in a fine tuning, maybe you want to scale out too, if you're going to fine tune with a very large data set, and then you need a pretty powerful GPU for that. So in that case, you may want to, but yeah, that's something I want to explore further in the future, like the fine tuning. But that's
Cool.
Good question.
Hey, this is great. Always something fun to learn. And let's see. I don't see any more comments, so I don't know, Roy, if there's anything else you want to, I don't know, any other scenarios you want to talk about? Otherwise, we could start to wrap it up, and then
Yeah. So
show your contact information for how people can get a hold of you.
Yeah. So with the whole kind of this AI kind of boom, right? Again, with my interest in Kubernetes, I just felt like this was a really cool thing to like deep dive into, right? And especially where my experience has been very more large enterprise with kind of regulation, and maybe this is something that's good to know and kind of dive into and kind of learn, right? So I find this topic really fascinating. So if you, again, this slide right here, those are my socials and contact. I am publishing a short and concise video of this talk, down to like 15 minutes, and watch out for it on my YouTube channel. So that should be published in a couple of days. But yeah, reach out if anyone has questions. Glad to connect and help.
All right, that's great. Thank you, Roy.
Okay, cool.
All right, concludes tonight's session. So thank you for joining us. Thank you for being here, Roy, and look forward to our next session.
All right, awesome. Okay, take care.
Thank you. Okay, bye-bye.
Bye.